All right, this is part 3 of chapter 8 of this book. We're going to do sorts. What's a sort? It's how we get things in order. We looked at, remember the binary search, previous video? It's really exciting. Go back and watch it. In order for the binary search to work, you have to get the list in order, the array in order. And that's very common. There's a lot of computer sciencey things that require your arrays to be in order. So how do you do that? Well, there's actually lots and lots of ways to do it. It's called sorting. And there's lots of sorting algorithms, approaches to how you can sort an array of things. We're going to look at 3 today in increasing levels of complexity. We'll start with the first one, and it's called the selection sort. And how this works is really simple. If I have 15, 3, 5, 0, 20, -2. Okay, a list of stuff out of order. What it's going to do is simply use nested loops to go through each position of the array and figure out what number is supposed to go there. So we're going to start, like, for example, here. Okay, there's 15, right? So now what number should go there? Well, the lowest one. Okay, fine. So we iterate from this position. Let's call this, I. We're going to go from I plus 1, which is here, all the way to the end. And we're going to find the lowest number. Well, the lowest number is what? 2, right? That's the lowest number. Then when we find that, when we swap it, say there's 15, here's -2. So now what do we know at this point? Nothing, except that the first one is right. The rest of these, who knows? The first one is right. Okay, then we go to the next one. We go to the next position. So now I is here. Okay, I plus 1 now goes to this position. Okay, and so we're going to say, well, what's the next lowest one? We go from I plus 1 to the end. Well, the next lowest one is 0. So we're going to swap 0 and 3. So what do we know now? That the first 2 are absolutely correct. The rest we don't know. You see how this goes. Move I over here. Then we go from this position to the end. So what's the lowest one in the rest of this list? That's lower than 5 is 3. So you swap 3 and 5. Okay. Now we're here. I is here. What's lower than 5 in the rest of the list? Well, nothing. We didn't find any that were less than 5. So 5 is correct. We just leave it alone. Okay, go to the next one. Go to the next one. Is 15 lower than 20? Yes, it is. And ta-da, we have a sorted list. That's all it is. Okay, this is pretty simple. Like I said, we just use a couple of nested loops. All right, so here they're going to end the book, and again, I'm going to follow your book so it's somewhat clear when you review it. They put it in a method. So public void selection sort. Okay. Int nums. Okay. So we just pass in a list of nums. It's going to sort it for us. By the way, this is kind of bad style, because it's going to change nums. Technically, you should make a new array that's sorted and pass that back so you don't modify what's been given to you. That's kind of impolite. But anyway, different topic for a different day. We'll go with what's here. We're going to sort this list. Okay, so for int I is equal to 0, I is less than nums length 5 plus. Okay, this should look familiar, right? you're gonna go through each one of the nums, 0 to the end. Okay, so for each one, we're gonna say int position is equal to I. Okay, that was my arrow that I drew on my picture a minute ago. For int k is equal to I plus 1. K is less than nums length k plus plus. Okay, so this, you see the pattern here already. Remember the top arrow that was moving along? That's I, and then here's the I plus 1. They're going to call it k. So it starts on the next one. Okay, so now here's your if statement. If nums k is less than nums position is equal to k. All right, so what's going on here? Basically what we're doing now, we started our position at I, but what we're trying to do is starting from that position I, going from k plus 1 to the end, we're trying to find the lowest one in the remaining part of the array we haven't looked at yet. So for the very first time through, it's the whole array. And then for the next time through, it's the whole array except for the first one. Next time through, it's the whole array except for the first two, and so on, just like we did in the picture. And so we're using position, pos, that will ultimately point to the index in the array with the lowest value, the next lowest value, okay? So at the end, basically, what do we have to do when we find the next lowest value? Anybody remember? I can't hear you, YouTube. Okay, the next lowest thing, when we find it, we're gonna have to swap it. So how do we swap it? It looks like this. Int temp equal to nums I, nums I is equal to nums pos equal to temp. That's it. Okay. Okay, so again, remember just picture the arrows, right? The top one, I'll draw the picture again. Right, remember we had all these little boxes of the array. Here's I plus 1, that we call k here in this loop. And remember how that works? Okay, and then what pos does is it starts at I, it goes to the end. So pos is basically going this way. And it's finding the lowest one that's left. You know, what does that mean? That means if we've already done a few of these, let's say the first, these are done. Here's I. So here's I plus 1. Pos is going this way. Okay, so if we've already done a few of these, then this one's done and this one's done. So pos is looking at the ones that are left and finding the lowest one. And it's not, the pos is not going to be the value of the lowest value, it's going to be the index into the array, pointing to the lowest value. In other words, which box is it? Okay, so when we find whatever that is, then at the very end we swap. Now what does a swap mean? Let's take a quick look at that, because it's a common thing. Let's keep it simple. Let's say we're swapping, this is 1, let's say 4, 5, and 6. Here's 0, 1, and 2. So we're swapping, let's say it's down here 1 and 2. So in this case, temp is equal to, I'm sorry, I would be equal to 0, and pos would be equal to 2. Well, let's make it real. This is 2. Okay, so we're swapping this one and this one. So what are we doing? We're using a temporary variable. So we're saying temp will be equal to nums I. Well, what's nums I? That's 4. We wrote 4. Okay, then nums I, that's this box, is going to be equal to nums pos. Pos is 2. This is pos, this is I. So that means this will now be 2. Remember, it's a computer. We can't just magically switch it. You can only do one step at a time. So now we have 2 and 2. Where did the 4 go? Well, we have it saved over here in temp. It's saved over here. Okay, and then finally, we say nums pos, that's over here, is going to be temp. What's temp? That's 4. Okay, there you go. There's your swap. This is very common, 3-step swap. That is the selection sort. That was the easy one, right? No problem. How hard could that be? What could go wrong? Next one, there's 3. What's the next one? The insertion sort. All right. This one, well, it's more complicated. Let's start here. 5, 3, 16, -3, 0, 100. Okay, so mixed up list. So there's different ways to attack this, but I think the way this book does it is from the end. So we start with 3. Let me make sure that's how they do it. Yeah, that's how they do it. Of course, I picked the hardest example. Okay, so they basically would say temp is equal to 3. Take the last one, right? Okay, then we just pretend this box is empty now. Okay, so that's 3. And then now we're pointing back, we're going back this way. So now we're pointing at this box. Is 3 less than 16? Yes, it is. So then we're going to move the 16 over here to that empty box. Now we go back over here. Is 0 less than 3? I'm sorry. Is 3 less than 0? No, it's not. So we're going to put the 3 here in this box. Okay. So we've successfully done this one. Seems like it's not going to work, but let's keep going. So now we're here. We say temp is equal to 3. This can't be right. I have the algorithm wrong. Because that would just stop, and that's obviously not sorted. Oh, I see. That's right. It's an insertion sort. So we have to actually, this array here has to be sorted already. And so the insertion, you're adding one more to the values that are already sorted. So let's try this again. Actually, let's do this. This will help me. I'm confused because there's multiple ways to do this. Let's look at how the code does it, and then that'll become more informative. Okay, public void insertion sort. Okay, same thing, int nums. Okay. 4 int is equal to 0. I'm sorry, start at 1. plus. All right. Int temp. Copy this down real quick and then we'll figure out how it works. Which is, by the way, how you learn a lot about coding is tracing through something. Plus 1 equal to nums j minus minus. Okay, let's see if we can figure out what's going on here. Just looking at this casually, we can pick out a few things that are going on. This nums j plus 1 equals nums j, that's how you move things this way, right? So this one is equal to this, so we're moving, that would move like this. Okay, that's what that's doing, and then we're working backwards, okay. Nums j plus 1 is equal to temp, so we're using temp. Remember the three-way swap? Same kind of thing here. We're using temp and then reassigning it. So those two things are going on. Okay, let's see what we're doing. So we're gonna pass in this array. Let's trace through this and learn about it together. Our i's equal to 1, so we're starting here. We're not starting at 0. And I'll write this out so it's a little nicer. I select nums. Okay, so we go to the end. So we're going to start here to the end. This is I. Okay, so temp over here is equal to nums I, so that's 100. Okay, int j is equal to I minus 1, so j is 0. Okay, so while j is greater than or equal to 0, it's equal to 0, that's fine. And nums j, what's nums j is 5, is greater than temp. Okay, well it's not greater than temp, so I don't care about any of this. It's not going to do anything. Okay, so j plus 1 is I, so it's just going to put 100 back in that box. So basically what that's done in the first iteration of this loop, here we have I and j, it says these two, forget about the rest of this, these two are already in sorted order. They are, 5, 100. If that was all the list we had, we're done. Okay, let's go to the next one. So now, here, we have I is here, and this is j here. Okay? While j is greater than or equal to 0, it is. Okay? And nums j, 100, is greater than temp. Well, in this case, temp is -3. Oh, well, 100 is greater than -3. So we're going to care what goes on here now. So nums j plus 1 is this. It's going to be nums j. So now this is going to be 100. You guys see how we're doing this trace? So j minus minus, so now j is over here. Okay, is j greater than or equal to 0? Yes, it is. Okay, nums j, 5, is nums, is 5 greater than temp is -3? Is 5 greater? Yes, it is. So we're going to keep going. J plus 1, that's here. It's going to be j. So we're going to move 5 over here. J minus minus. So now j is off the edge of the world here. So, okay. So, and then nums j plus 1, which is 0. So now j is -1. So this is 0 is equal to temp. So now we have -3. It goes here. So now we loop around again. Temp is equal to, did that wrong. What was here before? 5, I think. So now we loop around. Is j greater than or equal to 0? No, it's not. Now j is negative. So now we come back here and we put the -3 here. And we're done. So now the first 3 are done. Okay, I'm not going to trace through the rest of this, but you kind of get what's going on here. It's moving I each time, and then what it's doing, it's taking I, like if we put I here, now we're looking at this value 0. And it's basically saying, where does this go? And I'm going to keep sliding things for this, this is the good part. This part here is known to be sorted. It's done. So I'm going to take this 0 and insert it somewhere where it goes in order. And so all of this stuff here is comparing it down here to see where does it go in this list. So for 0, it would go boom, boom. It would slide the 100 over. It would slide the 5 over and say, oh yes, it goes between the -3 and 5. So it would put it here. And it would repeat that until we're done with I, and the whole list is sorted. Okay. Appreciate your patience on that one. I wasn't clear how the book was explaining to do it, but the code does make sense. And again, I encourage you to trace through it like I did if it's not clear. And that's a good way to learn what a piece of code does anyway. All right, that's insertion sort. So there's one more, and we're not going to go through the entirety of the last one because it is quite complex. But I will introduce you to it. This is called a merge sort. And what a merge sort does, let's get our list back up here. 16. Okay, something like that. How many boxes do I have? 3, 4, 5, 6, 7. Just put one more, just for fun. Okay. Now what a merge sort does is it breaks the problem down into smaller and smaller problems. And it uses a concept called recursion, which this is a terrible thing for your book to do. It introduces a programming concept it hasn't taught you about yet. It doesn't talk about recursion until a couple more chapters. So that's unfortunate. I'll give you a quick tour. A recursion is simply a function or a method that calls itself. Okay. It's quite tricky because just like an endless loop, you can wind up calling yourself again and again and again and again. And if there's no way to stop yourself, you'll blow up. But we're not going to get into that in this chapter, which I'll just tell you that's what it is. Because what happens here, for a merge sort, is it cuts the problem into smaller pieces. So in this case, it'll cut it in half. 1, 2, 3, 5, 6, 7, 8. So 1, 2, 3, 4, 14, 3, 90, -2. And over here, we have 16, 1, 5, 0. Okay, so now we have 2 smaller lists. Well, that's easier, right? Less work. We can keep dividing. Okay, what's that look like? Now we're down to the smallest possible list. They only have 2 elements. Well, that's stupid simple. It's like, do you just look at the 2 elements and say, all right, is it in order or not? Well, this one's not. Fine, flip them around. That was easy. Same thing here. Same thing here. Same thing here. I guess they're all out of order. Okay, fine. Now we have 4 little mini lists that are properly sorted. Let's get rid of this layer. So then what you got to do is smash them together, up a level. So smash these together sorted, what do you get? 3, 14, -2, 90. Well, put them together in sorted order. And what do you get? You get -2, 3, 14, and 90, right? So now this list is sorted. Now we're gonna put these together in sorted order. So we get 0, 1, 5, and 16. Okay, great, so now that's done. Now you smash them all together. right? Okay. So you get -2, 0, 1, 3, 5, 14, 16, 90. Thank you very much. It takes years of education and talent to do that. No, we're not done. I was just bowing for sorting the numbers. Okay, so anyway, that's how this works. You break the thing down into smaller bits, do the easy ones, and then smash them all together on the way back up until the whole thing works. And that's where you get this recursion idea, things calling itself. Because it's like, okay, how do you sort a list? Well, you sort 2 smaller lists and then smash them together. And then just keep going like in layers, like we've got it drawn. Now what's this look like? Again, I'm not gonna go through all the code here just because it's quite tedious and you guys haven't really had recursion, but I'm gonna show you the recursive part. Just so you have some familiarity with it. In your book, you can look at it. It's quite long. I actually encourage you to. The merge piece is the one part that we're not going to do because it's too complex to describe here because it's like 50 lines long and I don't want to write it all down here on the board. But you know, what it's doing is just what I did manually here. It's smashing the smaller pieces back together in order. Okay, so what they did here is this: public void merge sort int nums. Okay, that looks familiar, right? Pass in an array. Int temp is equal to new int okay, it's going to use a temporary array. That's exactly the same length as what you gave it. Now just pausing there, you'll see one of the shortcomings of this approach. It has some good points, but one of the shortcomings is it uses extra storage. Not a problem if you're sorting 8 boxes. If you're sorting 500,000 boxes, that's chewing up a lot of memory times 2, right? So all of these approaches have pros and cons. All right, what does it do? Merge, sort, helper, nums, 0, nums, length, -1, temp. Okay, what on earth is this? Because that's all this does. That's the merge sort, except for this grand mystery. What's that? You see there's all these mysterious parameters, arguments we passed in. There is a nums, which is the whole array. There's a 0, a length, and this whole temporary array. What is going on with that? Well, it becomes a little bit clearer when we look at the description of the helper. Okay. So before we get into this sheds a little bit of light on things. Okay, we got the original array, fine. Low, high. Okay, so we're gonna start with 0 and the whole, this is passing in basically the start and the end of the whole array. Makes sense, okay? Because remember at the top we had those 8 boxes, we're starting with the whole thing. And then this temporary array, we still don't know what that's all about, but spoiler alert, it's used as a scratch pad. We don't want to mess up the original one until we're ready, until we're done. So it uses this as just a work area. All right. This will look somewhat familiar. Okay, so first of all, low and high. Remember how in the, what was it? Was the binary search? Is that what it was? I think it was. Checking myself. Yeah, the binary search. Remember how the front and the back could get crossed when it's done? Same thing here. And we found the middle like before. Same thing here. Low plus high divided by 2. So this is all familiar. Here's the magic. So what are these two things doing? Remember what we did with the mid, we're cutting the list in half. We did the same thing with this thing in the picture when I drew it. You cut the list and had the array in half. So this merge sort, it's calling this guy again. Basically what this is saying, it's promising to sort the chunk of the array you give it. Okay, maybe I should have explained that. What this helper does is whatever you give it, it promises to sort that chunk. So up here you gave it the entire array. And so somehow, we don't know how, somehow it's going to promises to sort that whole array. Okay, so down here, while we're figuring this out, we're basically saying, okay, we're going to cut the array in half. Here's the first half from from low, which is 0 the first time in, to the calculated midpoint, the half point. So from 0 to mid, that's the first half. Call itself again with that chunk. And remember, we promised that chunk would be sorted somehow, right? And then we're going to call the same thing again, this time with the back half. Mid to the end. Mid plus 1 to high, right? So we're going to do that. We're going to call this again. Now what happens when it gets called again? It goes through the same process of cutting it in half. It keeps cutting it in half, cutting it in half, and sorting each chunk. Isn't that what I drew with the boxes? Every time I kept breaking it into half and half and half and half until it got smaller and smaller, until finally low minus less than high. That basically means you can't cut it down anymore. You can't subdivide the problem anymore. It's at its smallest point, those two boxes, right? And so that's what the recursion does, is it calls itself again and again with smaller pieces of the problem. In this case, cutting each piece in half. Okay, we're almost done. There's one more piece of magic though that goes here. And that's the part that we're going to kind of wink at and not go through too much. It's this. Okay. Merge. Basically, when I said that these things are going to sort each half, I should be a little clearer. Where are those sorted pieces going to be? Okay, remember I kept drawing these boxes. But the way this actually works, here's the original array, right? Here's temp. Same exact size as the original array. And so as, let's see, 1, 2, 3, 4, 5, 6, 1, 2, 3. Okay, so if we cut it in half, okay, this is, let's say chunk 1, and this is chunk 2, right? For the two halves. When I drew the example before, I actually just drew another layer in 2 sets of boxes. But in the way the program actually works, it actually is going to use 2 chunks of temp, right? And they're not going to smash into each other, but they're going to sit in the same array. So this first chunk here that goes in merge sort is going to use this one, the first half. The second one is going to use this part of temp. This is temp. And this is nums. Or also x. It's x when you get back down into here. Okay? Does that make sense? It's a little confusing because I drew it as separate layers. Okay? So essentially, I've got these 2 sections that are all working in temp, but they're working in different parts of temp. They're not going to smash into each other. Okay? Now when we get to merge, what this is going to do, you're passing temp in here. It's going to smash these 2 pieces together in such a way that, remember how I sorted the numbers manually to kind of get them all to work together? That's what this is going to do. It's going to merge the 2 halves together in temp and then dump them back into X. So that basically, finally, when all the magic is done, all of this work goes back into X, and voila, we have a sorted original list. That's how this works. So merge, like I said, look at the book. It's not complicated, it's just long, and it would take me another half hour just to write all the code and explain it all. But that's what it's doing. It's taking the pieces of temp, and of course, as you keep going, it's just chopping temp into smaller and smaller pieces. Okay, and as you go up each layer, it's going to combine each piece in temp until finally you get back up to the top, smashes it all together, dumps it back into the original array. It's all sorted. As you can see, this is pretty cool, but it's obviously way more complicated than where we started with the selection sort. Okay, pros and cons to all these, different methods, different value for different applications. Those are the 3 sorts: selection, insertion, and merge that the AP people want you to know. All right? We're done. Thank you.